Hello everyone, it's Tim from Arcana. In today's White Belt training video, we're going over DMVPN and best practices as it pertains to a MEVO managed environment. Now, I'm sure many of you are already familiar with the term DMVPN. It stands for Dynamic Multipoint VPN, and it kind of was advertised as a replacement for MPLS back in the day when DMVPN was a huge buzzword. Today's big buzzword is SD-WAN, and we're going to go over kind of the differences between DMVPN, SD-WAN, and how DMVPN, when used in a MEVO environment, is basically a software-defined WAN. Let's get started. DMVPN can be thought of as configured in three different phases. Phase 1 is your basic spoke to hub, so your basic VPN connection. Phase 2 is what some people call spoke to spoke. I call it spoke to hub to spoke. In this example, for spoke A, if it wanted to talk to spoke B, it would have to talk to, say, data center 1. Data center 1 would have to take all that traffic and send it down to spoke B. Spoke B would have to return all that traffic back up to data center 1. Data center 1 would have to send all that traffic back to spoke A. Now, phase 3 is where things can get a little spicy. Here, we're going to use a protocol called NHRP, Next Hop Resolution Protocol. Spoke A is going to tell the data center, hey, can you tell me how I can reach spoke B? And when that information is received, spoke A and spoke B can dynamically establish a tunnel to each other. And after a certain amount of time, when traffic isn't being sent between those two spokes anymore, that tunnel can dissolve. It can go away, thus freeing up resources on spoke A and spoke B. Now, if you had watched the White Belt video on architecture, you may have remembered that I said that the only kind of failure point in a DMVPN is with the hub routers. If your MEVO server drops, if your ICE server drops, if your SDP router drops, none of that's going to affect your tunnels. But obviously, since the hub router is your termination point, if that drops, then so too can your tunnel. Now, it's very easy for us to achieve redundancy. We can set up multiple clouds, for example, where a spoke router can connect to 2 different data centers, 3 different data centers, 4 different data centers. We can also establish multiple hubs per data center, and spokes can dynamically route their traffic based on whether or not a certain hub is online. All of your hubs actually are in an active setup, so any spoke router can reach any given hub at any given point. It really just depends on how it decides which route back to your data center is the best. So it's very, very easy to scale. And one cool point about DMVPN is, although it used to be Cisco proprietary, other vendors have been able to add support for DMVPN. So with MEVO, for example, we're actually able to provision Cradlepoint devices as potential spokes. Let's take a look at our example topology again, now that we've understood a little bit about DMVPN. Here our spoke router, using our zero-touch provisioning process, is able to connect back to both of our data centers. But that's not all. Remember how I said MEVO can configure devices past the edge? Well, with MEVO, once we establish that DMVPN connection, we can reach any of the other devices at the remote site if those need to be configured as well. This allows us to do zero-touch provisioning on devices that are past that edge device. As I mentioned earlier, another benefit of DMVPN is it does allow us that spoke-to-spoke communication, and because that is a dynamic connection, we're only going to use that connection when the traffic needs to be passed from spokes. This allows us to be very efficient with our resource use because we don't always have a certain set of resources that are always blocked off or reserved or essentially being wasted whenever we're not using that spoke-to-spoke connection. MEVO also comes with a built-in IPAM solution, and it can integrate with info blocks. So whenever you do set up a remote site, and whether you're setting up just the edge or devices past it, MEVO can handle all the IP addressing for you. There's no need for you to plug in each and every individual tunnel IP address or LAN IP address that goes at each remote site. Now, I understand that DMVPN is kind of the older buzzword, and I talked a little bit about SD-WAN. So let's do a little bit of myth busting, shall we? First of all, even though DMVPN is the older solution, it is still very secure. It supports RSA and EC-based certificates, not just pre-shared keys, and MEVO handles and primarily does its zero-touch provisioning using an RSA certificate. We can do some other special things in order to do EC certificates, but it's a little bit too advanced, I think, for just a white belt level certification. DMVPN is also compatible with EIGRP, allowing us to get the newer and better security features that aren't available in EIGRP. As I mentioned earlier, even though DMVPN is a Cisco technology, other vendors are able to use DMVPN now, including Cradlepoint. We are able to do that zero-touch provisioning process on a router, which I think is one of the major benefits of using an SD-WAN, is that you're able to do a zero-touch provisioning of the spoke. Well, we too also do zero-touch provisioning of spoke routers, and we've been doing this for, I think, over 15 years now. So in many ways, MEVO is kind of the original SD-WAN solution. It is the original intent-based networking platform. And because we're using, a more classic CLI-driven technology, this means that it's very customizable. For example, within our routing for DMVPN, we can use the routing protocol of our choice. Now, we typically recommend EIGRP, but you can also run BGP. It really just depends on you. Speaking of routing protocols, here's a quick summary of the 3 main types of routing that we would recommend you use for DMVPN. EIGRP is what we recommend because it's easiest to configure and also gives you the fastest convergence. We can also designate a primary or secondary DMVPN hub by kind of playing with the delay values that go under your tunnel interfaces, and it supports BFD. Now, if we compare that to IBGP or EBGP, those will give us a bit more control over our path selection. They also scale a lot better than EIGRP does when it comes to extremely large environments, and they also support BFD. It is a little bit more complex and it is slower than EIGRP, however. And one thing I would like to point out is, again, even though EIGRP is a Cisco proprietary routing protocol, Cradlepoint also supports EIGRP. This pretty much covers everything you need to know about DMVPN as it pertains to MEVO. If you have any questions, let us know, and go ahead and take a look at our supplementary lab videos. That'll give you a lot better look at how all of this works.